All right, guys, I hope you're all doing great. So this is either for the last day of March for the Monday, Wednesday class, or April Fool's Day for Tuesday, Thursday people. So this is not an April Fool's joke. But we are doing section 4.5 today, which is called combining functions. So let's see what's going on tonight. 4.5. So that's your homework in Hawks. All right, so when you have two different functions, these directions are going to tell us that we're either going to add those two functions together, or we're going to find the difference of them, or the quotient, which means we're going to divide them. And then there's other functions where you take one of the functions and you implant it into the first function. So let's see what these are going to look like. All right, so I know this is confusing when you first look at it, but let's see what it says. It says, given that f of -2 equals 5 and g of -2 equals -3, find f minus g of -2. All right, so when they put f of -2, it means that they've taken a function, they've implanted -2 into it, and they got an answer of 5. They did that also with this function. And then they want us to subtract this answer and this answer. Okay, we're doing this part first. So since they've already implanted -2 into both of these functions and they got 5 and -3, they want us to subtract 5 minus -3. You have to follow the order, F first and then G second. And then we're going to do our bam bam. So 5 plus 3 is 8. So that's the answer. And then they say that they want us to find the quotient of F divided by G of -2. Well, once again, they've already plugged in -2 and they got 5 and -3. So this time they want us to find the quotient of F over G. So that would be our final answer. Okay. All right, let's look at some more. Now this time it says f of x is equal to this expression, and g of x is equal to square root x. It says find f plus g of x. Well, this is f of x and this is g of x. So they just simply want us to take f and add it to g. So f is 4x squared minus 1, and we're going to add it to g, which is square root x. Now, if there was anything for us to combine, we would actually combine like terms, but there's nothing to combine, and so we are finished. That's the answer. All right, so basically that was the last one we did, and I got that answer. And so you need to read this. You need to read over it, pause the video, read over that, and just try to understand what that is saying. So as we practice these, they're gonna, you know, get a little easier. They look very confusing right now, but all right. So composing functions. Let f and g be two functions. The composition of f and g denoted f. Oh, I don't know what that little. Let's see. Does it give us a definition of that word? They're gonna. Oh, it says it's read f composed with g. So that's how this is read. F composed of g is the function defined by f composed of g of x. And so if we distribute this right here, this would be g of x times f. Okay. The domain of f composed of g consists of all x in the domain of g, for which g of x is in turn in the domain of f. Oh my goodness, what does all that mean? All right, let's look. Now this just tells you that basically if you're adding or multiplying whole numbers, you can use the commutative property and you get the same answer. But when you're actually composing functions, there's not a commutative property. So you have to be careful with the order in which you do these problems, because the order does definitely matter. All right, so basically the way this is written, F composed of G, you're going to take whatever is second, you're going to take that quantity and implant it into the first letter. All right, so do you see that this is an F and this is a G? It says we're going to take G and we're going to implant it into F. But we also are going to go ahead and substitute 6 for X in that first function that we're going to deal with. We're going to deal with G first, even though it's written second. You always take the second function and you put it into the first function. So the first thing we're going to do is right here, we're going to plug in 6 for X. Well, 6 minus 3 is 3. So now G of 6 is equal to 3. So now we're going to take 3 and we're going to implant it into the function of F. So 3 squared is 9. So our answer is 9. All right, let's try another one. All right, so let me erase all this stuff. So once again, the way it's written, you take that second letter and you're going to deal with that one first. You're going to take F, you're going to implant it into G. Well, so we're going to take this 6 and we're going to plug it in for X right there into F. So 6 squared is 36. And then we take 36 and we implant it into G, which is 36 minus 3. And the answer is 33. That's the answer. All right, let's look at letter C. So we're going to take G and we're going to plug it into F. Now this time they did not give us a specific number, which means we're going to take all of G of X, which is all of this, and we're going to implant it into F of X. So that X is X minus 3, and it says X squared. That means we're going to multiply this thing by itself, right? X minus 3 squared is the same as X minus 3 times X minus 3. All right, now, okay, anyway, so we can FOIL this, right? So we're going to multiply the first two, we get X squared. We're going to multiply and we get negative 3X. These inside terms is negative 3X, and negative 3 times negative 3 is positive 9. So when we combine like terms, we get this. This is the answer for letter C. All right, now we're going to take F and implant it into G. So we're going to take F, which is X squared, and we're going to implant X squared into X in our second one. So there's our X, which is X squared minus 3, and there's nothing we can do to that. So that is the final answer. And what they were saying earlier is normally with whole numbers, you could, 5 times 3 is the same thing as 3 times 5. You get 15 either way. But for these compositions, you get different answers. So you always take what's listed second and you put it into the first letter. All right, so I got these straight from Hawks. I want to start with this example first, the second one down here. Now this one, we're adding together F and G, and they want us to implant 3 into both of these equations for X, or expressions for X, okay? So we're going to take both of these, and this time we're just adding them together, right? So we're going to take 3 and we're plugging it in for both of the variables for both of the different functions. So we have the absolute value of 3. So absolute value is always positive. So the absolute value of 3 is 3. So that's the function of X equals 3. And then here we have X, 3 plus 1 is 4. And then finally we're going to add F plus G, and the final answer is 7. Okay. Now this problem is a little bit different. So this tells us to find the quotient of F and G and they want us to, you know, make our unknown variable a -3. Well, basically, the way this is written, they've already put in -3 for a variable, and the answer is 13. So you see, we don't have any variables in either one of these functions to substitute a -3 for. They're showing us they've already implanted a -3 into each of these equations. So all we have to do is simply write f, which is 13, divided by g, which is -8. So that -3 is here just to show you -3 has already been implanted into two different functions, and they got an answer. And then we take those answers and we divide 13 by -8, which can't be simplified. So that would be the answer you put into Hawks. Alrighty. All right, now all of these, I think I gave you 4 examples. No, anyway, I've given quite a few from my open math. So you'll have problems very similar to these. All right, so the first thing I see is we have f of x and g of x is this, and it tells us that we're multiplying. Now this is different from this. This is where if it looks like the word fog, F-O-G, you would take g and implant it into f. But that's not what it shows us. It's just saying we're simply multiplying what is f of x by g of x. That's what it says. We're going to take f of x and we are multiplying it by g of x. So we have to FOIL it. So we're going to do first 2 terms, x squared times x is x to the 3rd. And then outside terms, -2 times x squared is -2x squared. And then -1 times x is -x. And then -1 times -2 is +2. And that is our answer. Okay. All righty. Then it says we're going to divide f by g. But for all of the variables, we're going to plug in -3. Okay, so this is a different problem. So we're going to plug in -3. We're going to get -3 squared plus 8 times -3 plus 15. So let's type that in our calculator. -3 squared is 9. 8 times -3 is -24. Plus 15 is 0. So our numerator is 0. We're allowed to have a 0 in the numerator. And then I'm going to plug in -3 right here. -3 plus 8 is 5. So 0 divided by 5 is 0. And that is the answer. All right, and then you're going to have several that look like this. So basically you take what's inside and you plug it into what's on the outside. So we're going to take g of x and we're going to plug in x plus 3 for our x's and f of x. So this x is now x plus 3. So I'm going to do x plus 3 for x, and then it says squared plus 6 times x, and x is x plus 3. Right? So x plus 3 squared plus 6 times x is 6x, and 6 times 3 is 18. So now we're going to FOIL this, so we get x squared plus 3x is 6x, and 3 times 3 is 9 plus 6x plus 18. So now when we combine like terms, we get x squared. And then 6 plus 6 is plus 12x. And 9 plus 18 is plus 27. And that's our answer. Okay. All right. I'm going to erase all that. Y'all got it? So now I'm going to take what's inside f of x, and I'm plugging this into g for that x right there. So we're plugging in x squared plus 6x. So that's our x plus 3. And guess what? That's our final answer. There's no like terms. There we go. Alrighty, this time we're going to take f of x and we're going to plug it into, guess what? Itself, which is weird, right? So we're going to take the whole expression and we're going to plug it into itself. So what am I going to write for this x squared? This x squared is going to be x squared plus 6x. That's our x, and we're squaring it, plus 6 times x. Well, x is the entire expression. See how that works? You're putting it into itself. So we're squaring. Let me get rid of this right here. We are going to square x squared plus 6x Let's do that first. So x squared times x squared is x to the 4th. X squared times 6x is 6x to the 3rd plus 6x to the 3rd plus 36x squared. All right, so then that'll be x to the 4th plus 12x to the 3rd plus 36x squared. And then the rest of it was this part, plus 6x squared plus 36x. So now we're going to combine all like terms, which is this term and this term. That's it. So letter C should be x to the 4th plus 12x to the 3rd plus 36 plus 6 is 42x squared plus 36x. That is our answer for letter C. Okay. All righty, and then let's do letter D. So we're going to take g of x, where's my pen, and we're going to plug it into itself. So this x right there is the whole expression, x plus 3, that's my x, and then I have to put plus 3. So basically it's x plus 3 plus 3, so the final answer is 3 plus 3 is 3 plus 3 is 6. So that's the final answer. All right, so here's another one from my open math. So we're going to take f of x and we're going to plug it into our variable for g. Now this, they have this also, but for right now, we're not doing anything with this because right here in this problem, there's no g of x. Okay, so excuse me, there is a g of x. There's no h of x. So we're just going to ignore this. On my open math, you would use that in the next problem. But let's just look at this problem. So we're going to take this expression, we're going to plug it into g for that x right there. So on g, we're multiplying 3 times x, which is 5x plus 3, and then it says squared. So let's square 5x plus 3 first. So we get 25x squared plus 15x plus 15x plus 9. So we have 25x squared plus 30x plus 9. And now we're multiplying all of that times 3. So 3 times 25x squared is 75x squared plus 3 times 30 is 90x. And 3 times 9 is 27. And that is our final answer. Okay. Oh, was that it? That was it. All right. Well, what do you guys think? I'm hoping that was enough examples to help you feel confident. But of course, come to class, ask me any questions, and I will help you with any of your homework problems. All right, guys? All right. I'll see you guys later.